Hi everyone, I'd like to welcome you to Mr. Q Does Math, the video show where Mr. Q, that's me, does math problems. Hey guys, so today we're going to be working on dividing and multiplying rational expressions, and we're going to do 4 problems, so let's just get into it. So this is the first one, and our first step in these problems is going to be to change the division of fraction to multiplication. The way we make it multiplication is by multiplying by the reciprocal of this piece. And just to review, the reciprocal happens when you invert the denominator and the numerator. So you just flip what's on top and put it in what's on bottom, and what's on the bottom you put it up to the top. So it'll look like this. This first piece will stay the same. It'll still be x squared over 10 minus 4y. And we'll change this to multiplication. And now all we do is put what's in the numerator into the denominator. So this will be x squared down here. And this will be 50 minus 20y. Okay, now that we've got that, our next step is going to be to factor. Okay, and let's factor from left to right. So we can't factor anything here because it's just one term. Over here we have a 10 minus 4y, so we can pull out a 2. So that'll look like, this will stay x squared over here. If we pull out a 2, it's going to be 2 on the outside, open parentheses. 2 times what gives us 10, and that's 5. Minus, how do we get minus 4y? That'll be 2 times negative 2 and y. So we have 5 minus 2y there. This is still times. And let's factor this piece. 50 minus 20y. So whenever you have two numbers that end in 0, you can divide by 10. So let's pull a 10 out. And what times 10 is going to give us 50, and that's 5. Minus, to get 20, we'll have to multiply 10 by 2, and we got to add our y here. And this is just going to stay x squared. So after we factor all the pieces, now we want to check our diagonals and up and down to see what can cancel off. So I always check the diagonals first, but it's up to you whether you want to check the diagonals or up and down first. So over here I have an x squared and an x squared, so that's nice. This will cancel, and this will cancel. And while you're new at these problems, I would definitely put a 1 here so that you don't forget and try to say that, oh, this is 0 here because it's canceled off. All you did was make it a 1. And then if you check the other diagonal, we have 5 minus 2y over here and 5 minus 2y over here. So we'll cancel these off and again replace them with 1s. And then again, still staying with this diagonal, we have a 10 and a 2. So since they're both even, we can divide both of them by 2. 2 divided by 2 is just going to be 1, and 10 divided by 2 is going to give us 5. So once we get that far, all we have to do to finish off the problem is multiply across. So we have 1 times 5 times 1. Let's move this up. 1 times 5 times 1 over 1 times 1 times 1. 1 times 5 is 5, times 1 is still going to be 5. 1 times 1 times 1 is just 1. And now we have 5 over 1, so we can simplify that into just 5. And that will be your final answer for this problem. Alright guys, so this is the next division problem. And we're going to do the same thing we did last time, where we take it as a division problem and we turn it into a multiplication problem. The way we do that is by taking the second term and multiplying by its reciprocal. So the first term we leave exactly the same. So it's just going to be x minus y over 2x plus 3y. This division is going to become multiplication. And now to get the reciprocal, all we do is take the second term and flip what was in the denominator, put it in the numerator, and put what was in the numerator into the denominator. So the 1 was in the numerator, so now it'll be in the denominator. And now this will be for x squared plus 12xy plus 9y squared. Okay, now that we've gotten that far, our next step is going to be to factor everything that we can. If I look at this, we can look at it as four separate terms. So our first term, x minus y, these don't have anything in common, so there's nothing we can factor. Over here, 2x plus 3y, there's still nothing there in common that we can pull out. Here's just a 1, but over here we have 4x squared plus 12xy plus 9y squared. And now this is where you definitely want to use what's given in the problem to your advantage. So in this unit, it's all about, simplifying. And so what's probably going to end up happening is that you'll simplify and then things will cancel. So use what they gave you. So since this is on the bottom here and we're going to be canceling on our diagonals, I would put this as your first factored term. You won't be able to do that every single time, but it'll work in this case because we're trying to figure out what two binomials will multiply into this trinomial. And since we're canceling, we can it's pretty safe to assume that one of the terms will be 2x plus 3y. It won't always be the case, but I would say 7 or 8 times out of 10 it will be. So to factor this piece, the first thing I want to put down is just the 2x plus 3y. And we need the second piece of that binomial. So I'll rewrite the rest of the problem first. So this whole piece stays the same. And with this part, we still have a 1 down here. We need to figure out what we can put in this term to multiply out to here. So we've got a 2x over here, and to get 4x squared, we need to multiply by another 2x. That way when we multiply it out, we'll have a 4x squared. And to get this 9y squared, what can we multiply by 3y to get 9y squared? And that's another 3y. If you FOILed it out, it would be equal to this because you have the 4x squared plus the 9y squared, and if you add the middle terms, you're going to get 12xy. So now that we've factored it, the next step is going to be to cancel on our diagonals and up and down. Up and down, there's nothing here that cancels, so if we look at our diagonals, we have a 2x plus 3y over here, and 2x's plus 3y's over here. So we can cancel one of each. We'll be left with one over here and one over here. And then, once we've canceled everything we can, we just multiply across. So this will be x minus y times 2x plus 3y over 1. And sometimes you can leave it like this, but if I have this, I would just distribute it out and have one term to finish the problem. So we'll just use the regular Punnett square method. So here we've got x minus y, and over here we've got 2x and 3y. So this is going to be 2x squared minus xy minus 3y squared when you're all done with it. And that's just distributing this out, which you can either use the FOIL method or you can use the Punnett square method. But this will be your final answer. 2x squared minus xy minus 3y squared. Alright, so now that we got some division problems done, let's look at what the multiplication ones will look like. We don't have to do that first step of turning it into multiplication since it is, so we can just move in directly to step 2, which is to factor all the pieces. So when we factor, we look at each piece and see if there's any common terms or common coefficients that we can pull out. So what I like to do is just label these as, 1, 2, 3, 4, and look at it piece by piece. So m plus n, they don't have any terms in common, so that's just going to stay as m plus n. M plus 2n, again, these have nothing in common that I can pull out, so this is just going to be m plus 2n. 2m plus 4n. Now the coefficients here, we can take a 2, they're both divisible by 2, so we'll pull a 2 out. Now how do I get back to this? So I'll have to multiply this by m to get 2m, and this by 2n so that we can get 4n over here. And then this bottom piece, this is nice and easy for you. There's a 5 on both sides, so we can pull the 5 out. And we'll have m plus n. So when we multiply it out, we'll get 5m plus 5n. And now our next step is going to be to see what things can we cancel off. So I look at my diagonals first, which is a habit of mine. So over here we have m plus 2n, and over here we have m plus 2n. So we can cancel these two off, put 1s. And over here we've got an m plus n, and over here we've got an m plus n, so we can cancel these off and replace them with 1s. After you cancel everything that you can, your next step is going to be to just multiply across. So over here we'll have 1, for the numerator we'll have 1 times 2 times 1 over 1 times 5 times 1. 1 times 2 is 2, times 1 is still 2, and 1 times 5 is 5, times 1 is still 5. Oops, sorry about that. So again, 1 times 2 times 1 is 2, 1 times 5 times 1 is 5, and then 2/5 will be your final answer to this problem. Alright, so let's get this last multiplication problem done and we'll be done for the day. So, with this one, we're going to start by factoring everything we can. So let's look at it piece by piece. This first piece, x minus 2, there's nothing we can factor because the two terms are completely different, so this will stay x minus 2. Over here we have a 3a plus 1, nothing can be factored off of that, so that'll stay the same. Over here we've got 6a plus 2. Now the 6 and the 2 are divisible by 2, so we can pull a 2 out, and we'll get, to get to the 6a we'll have to multiply by 3. 3a times 2 is going to be 6a. And we'll add 1, because this multiplied out will give us this term. And our bottom term over here, x plus 2, that can't be factored any further. So once we do all of our factoring, our next step is to see what cancels. Over here on the diagonals we have x plus 2, x minus 2, that doesn't cancel. But over here we've got a 3a plus 1 and a 3a plus 1, so we can cancel these. These become 1s. And with what's left, all you need to do is multiply across. So here we'll have x minus 2 in the numerator times 2. And in the denominator we'll have 1 times x plus 2, or just x plus 2. I would use the distributive property here and keep going. So this will be 2x minus 4 over x plus 2. And again, here you might be tempted to cancel off one of these x's, but just remember, these are quantities. And because addition and subtraction are not commutative, these values will change based on what your x is. So you can't just cancel one piece out of a quantity. Alright, well I hope that cleared some things up for you. If not, post a question to comments or email me, and I hope you have a great day. I hope you learned something.